Hi and welcome. Let's discuss this question, that is merge k sorted lists. So in this question you will be given k sorted list and we need to merge them into one complete list. Fine. So suppose we have the list as 1, 2, 3, 4, or let's say 1, 3, 5, 7, 9. Okay, 2, 4, 8, 10, 12, 13, 15, 17, 19, 21, 14, 16, 18, 20 and 22. These four sorted lists are given to us. Now we need to merge this sorted list into one complete list. Fine, that is what the question says. That's it. So do you guys know how to merge two sorted arrays? Given two sorted arrays, can you guys merge them? Let's say these are my two sorted arrays that is given to us. Fine, and we need to merge these two arrays. So what is the procedure to merge two sorted arrays? That is merge process of merge sort. Remember the merge process of merge sort? We will be using something similar to it. Same it is. So I is this and j is this, and my final array, let's say we have a k. So if element present at I is less than the element present at j, so at position k we will store that element. My k will increment and my I will increment. Now j element is less than I, so at k we will write the element of j, my k will increment and my j will increment. Now 3 is less than 4, so we will get 3, and since now k will definitely increment and now I will increment. Now 4 is less than 5, so j value will come here, k will increment and then j will increment, and so on and so forth. So if array of I is less than array of j, then we get that at our final array of k, write array of I, increment k and increment I. Else in our final array write j, increment k and increment j. Fine, this works till either my I is over or j is over. Okay, so while my I is less than n and j is less than m, where n is the length of the first array and m is the length of the second array. Suppose they are of not same length. Okay, suppose we have just two elements in this array. So j will finish first, depends on the condition. J may finish first. So the remaining I elements will be simply copied. If I finish first, remaining j elements will be simply copied. This is merge process of merge sort. The same process we are going to apply here. Can you guys just pause and think how? If you guys can do it, you will be able to solve the question on your own. Okay? You may know about merge sort already, the merge process already. I just gave you a brief recap, nothing else. Just try to do it on your own now. Given k sorted list, so you will have head of these lists. So we have the list with head 1, list with head 2, list with head 13 and list with head 14. So how can we merge this list into one single complete list? So one way to do is merge two lists at a time. Merge 1 and 2. We get a list, whichever is smaller, 1 is smaller. Then merge 1 and 13. Then merge 1 and 14. And finally we have our complete list. Merging two lists at a time, and with the result merge the third list, then with the result merge the fourth list, and so on. Suppose you have k such lists. Okay, so merging two sorted arrays, merging two lists takes order of n plus m time, where n is the length of the first list and m is the length of the second list. Fine. So we have to merge these two lists together, each two lists at a time. That's it. Okay, now the result list will be of size nm, and suppose this is of size something else j, and so on, the size will increment. So let's say there are total n nodes in the final list. Fine. So the time complexity is n into k, where n is the nodes in my final list. Okay, in the final list, this is capital N, because we have merged these many nodes together. Again, there were total k linked list. So merging two lists at a time, this is one of the approach to solve this question. A pretty basic approach. Just get the head of two lists, pass in this function, and it's done. So can we do something better? We can improve it. How? Let's see. So let's suppose we have 8 lists with us, and these are the heads of those 8 lists. Okay, so they all are linked list in themselves, and these are just the heads of those linked lists. Fine. Not, this is not a linked list, these are the heads of 8 linked lists. Fine. So what the approach says is simply like a two-pointer approach. Merge 1 and 8. Merge 1 and 8. 1 and 8. Store it in 1. Merge 2 and 7. Store it in 2. Merge 3 and 6. Okay. Merge 3 and 6. Store it in 3. Merge 4 and 5. Store it in 4. Then you have just 4 lists left. Again, do the same thing. Merge 1 and 4. One first and the last one. Merge 2 and 3. The 2 lists are left. Merge 1 and 2. Get a 1. So now what it is saying, previously what we were doing, previously we have 2 lists, we add it, we merge it, then we merge the result with the 3rd list, then we merge the result with the 4th list, then we merge the result with the 5th list, and so on. Okay, so it was going k times we have merged. Now what we are doing here in the first pass we are merging all the 8 lists. Okay, I am saying, let's say it is n, the number of total nodes we have, and we are merging those nodes. So total work done is order of n only. It's simple enough. We have taken all the list 1, 8, 2, 7, 3, 6, and 4, 5. All 8 lists we have taken, and everyone is taking n plus m time. Let's say n is the total number of nodes. Then again, it will still have order of n nodes only, and it will still have order of n nodes only. The nodes will remain same, correct? Means if you have total n nodes in all combined 8 lists, then they will remain same. Each time you are working on those n nodes only. And now how many times are you working? First you are working 4 times, then 2 times, then 1 time. If you have 16 such lists, so first you will work for 8 times, then 4 times, then 2 times, then 1 time. In 4 steps it will be over. Here in 3 steps it is over. 3 times you are doing order of n. Here you will do 4 times order of n. Each time the number of times you have to do is in logarithmic form now. Correct? Divide by 2 each time. So it is nothing but log k times. Okay, we are still performing order of n operations, but now log k times, where n is nothing but the total number of nodes. Remember, it is not one small n, not of single length linked list, total number of nodes in my linked list. Fine. In this part also what we were doing the same thing, but here we were taking just 2 nodes at a time and performing this one k number of times. Here what we are doing, we are not performing this k number of times, we are performing this log k times, and each time it is taking order of n number of operations. So log k into order of n log k. Okay, the process still remains the same. Now we just have a loop, that is I and k. So we simply merge this list with this list. Okay, then this list with this with this, this with this with this, and we perform this log k times. That's it. Still remains same. Fine. Now you may ask, sir, okay, we have merging 2 arrays, it's fine, but how it will work in linked list? So it is exactly the same. You have a linked list, let's say 1, 3, 7, 8, and you have another linked list 2, 5, 6, and 9. Fine. So you have this head 1, this is head 2, and the same process again repeats itself. Head 1 is smaller or head 2? Head 1 is smaller. So this is my result. This is the head of the result linked list because this is smaller, and we will now pass in our function. You can do it recursively and you can do it iteratively for the remaining list. Okay, now this is my h1 and this is h2. Okay, now which is smaller? H2 is smaller. So this will be simply result.next will be simply mapped to this, and h2 will work. Now which is smaller? So this dot next will come to this, and so on. It will be simply, we have to change the pointers. Whichever is smaller will become the next. That's it. We are changing the pointers in place here. Okay, not difficult. You will see in the code. It's pretty simple. Fine. And this we do how many times? For all the end nodes, log k times. That's it. So this is how you can solve the question of merge k sorted linked list. There are other ways also, and this is one of the ways, normal linear way, and another is divide and conquer way. Fine. So we have seen two of them. Let's see the implementation. So all the linked lists are created, and we are given a vector that is containing all the head lists, all the heads of the lists. Okay, in the head list vector. So first of all, let's get the size. K equals to head list dot size. Fine. So while k is not equal to 0, let's have int I equals to 0 and j equals to k. Fine. That means the first position and the last position that we are merging. So while I is less than j, simple. In head list of I, we will store the merged list of head list of I and head list of j. Fine. I plus plus j minus minus. If I becomes greater than equal to j, we will have k equals to j for the next iteration, and this will go on till k becomes 0. So we are merging. Okay, so the k will now be the midpoint after that, because after 8 it will become 4. So suppose it is 16, it will become 8. Correct? So for that it is given here. Now we just need to implement this merge. So we are merging two lists at a time here also, but here we are performing the overall operation log k times. Fine. Now let's do this. It will return a node. So single linked list node, return type, merge. It is taking two single linked list nodes as the input. Let name it x and y. We need to merge these two single linked list, okay, whose head are x and y. So let's define a result variable, single linked list node star result equals to null initially. If x is null, that means we have a null linked list. So in that particular case, if we have traversed everything and now my x is becoming null, so we can simply return y to be added. If y is null, then in that case we can simply return x. Fine. If x dot data is less than equals to y dot data, fine, so result will be x, and result dot next will be pass the remaining linked list in merge, that is x dot next and the y itself. So x will increment. So if I is less element at I is less than element at j, so increment I. Correct? That is what we are doing. Else result equals to y and result dot next equals to merge y dot next x. That's it. Finally return the result. So merging two linked list, you can do this iteratively as well, and this is the merge k list function. Let's run it. So we don't have test case. K value is, let's say, 4. Okay, so we'll have 4 lists. Let's suppose we have 1 3 length is also needed, I guess. 1 3 5 7 9. Let's say we have something like 2 8 10 12. Then we can have here 4, 6, 11, 13, 20, and we can have 14, 17, 19 here. And when we merge it, it's giving me some error. What is the error? Okay, fine, sorry. We have to return head list of 0. Finally, all it will be included in head list of 0. Fine, let's run it again. And we get the merged list. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 19, and 20. All it is merged in sorted order. So this was the implementation for merge k sorted linked list in n log k times, where n here actually is the sum of all the length of the linked list, complete length. That is important to note. Fine. Thank you.